lecture of our Roxali course, you will learn about a lot of things about Linux command line. So let's get started. When you work in the Windows, macOS, and most other operating systems, you probably spend your time running applications like web browsers, word processors, spreadsheets, and games. A typical application is packed with features, everything that designers or their users would need. So most applications are self-sufficient. They don't rely on other applications, so you might copy and paste between applications from time to time, but for the most part they are separate. But the Linux command line is different. Instead of big applications with tons of features, Linux supplies thousands of small commands with very few features. The command cat, for example, for example, the print files on the screen, that's about it. So the ls file, ls command lists the file in a directory, mv renames files, and so on. So each command has a simple, fairly well-defined purpose. What if you need to do something more complicated? Don't worry. So Linux makes it easy to combine commands so their individual features work together as accomplish your goal. So this way of working yields a very different mindset about computing. Instead of asking which application should I launch to achieve some results, the question becomes which command should I combine? In this lecture, you will learn about how to arrange and run commands in different combinations to do what you need. To keep things simple, I will introduce just 6 Linux commands and their most basic uses, so you can focus on the more complex and interesting part about that, combining them without huge learning curve. So it's a bit like learning to cook with 6 ingredients, or learning carpentry with just a hammer and saw. So you will combine commands using pipes, and here this is a pipe here in Linux. So this is the Linux feature that connects the output of one command to the output of another. So let me open my driver here, Gromit MPX here. So it takes one here. So if you have here, toggle painting, if you have one here, for example, this is our one result. If you make pipe between them like this will take here and put it here. So example will be practical for daily use, so while others are just toy examples to demonstrate an important feature. So let's get started with input, output, and pipes in Linux here. Yes, actually, how can we clear screen, shift and home? Yes, clear screen here. So most Linux commands read input from keyboard, write output to the screen, or both. So Linux has fancy names for the reading and writing. For example, stdin here. So this is actually not a command, but just I want to talk about this. So this stdin is standard input or standard in. So this is a stream of input that Linux reads from your keyboard. So when you type any commands at a prompt, you are displaying data on stdin. And we also have the stdout pronounced as the standard output or standard out. So this is the stream of the output that Linux writes to your display. So when you run the ls command, for example, to print file names, the result appears on stdout. So now this comes the cool part here. So you can connect the stdout of one command to the stdin of another. So the first command feeds the second. So let's begin with the familiar lsl command here. So lsl and bin here, for example. So as you can see here, the directory contains far more files. For example, if you have directory contains the more files than your display has lines, so the output quickly scrolls of the screen here. As you can see, it's shame that ls can't print the information on the screen full at a time. So pausing until you press a key to continue here, so like this. Or for example, slsm home, oops, home, and as you can see here, we got this. So let's actually also use the less here, for example, my file, and as you can see, we don't have a my file. So the less command displays a file on a screen full at a time. So you can connect these two commands because ls writes the std out and the less can read from the std in. So for example, lsl here, so let's clear, yeah, lsl here bin, and this is a pipe here, so use a pipe to send the output from ls to bin here. Oops, not like this here. So use a pipe to send output from ls to the input of less here. So in this case, the less is going to be less and just that. And as you can see here, we got an screen here like this. Oops, here, right? Yeah, here, as you can see here. So the combined command displays the directory contents one screen full at a time here. So the vertical path here, vertical path that we've written here. Yes, here press return to quick here, or for example, let's lsl home like this, and as you can see here, we've written like the output here like this. So first command's std out to the next command std in. So any command line containing pipe is called pipeline. So command generally are not aware that they are part of a pipeline. So ls believes it's writing to the display when its fact output has been redirected to less here. So and the less believes it's reading from the keyboard when it's actually reading from the output of ls. The word command has three different meanings in Linux. So the first is a command is just a program here. Just let's change my mouse. Yeah, command is just a program. So command is just a program. So this is an executable program named and executed by a single word, such as the ls here, ls, or a similar feature built into the shell, such as the cd here. Actually, let's see, yeah, ls, cd, cat, and goes like that. So we also, the command is also can be a similar command. So this is a program name or a shell built in, actually the simple here, simple. So this is a shell built in or optional followed by an argument, such as here the simple command is like ls, and here it calls the l here, and after that the, for example, home. So this is a simple command. And we also have a combined command. Combined command. So this is several simple commands treated as a unit in combined command here. So let's actually write something like that. So we have ls here. So after that it's l, and let's spin here, or home, and after that we are using the pipeline here, and then we are writing less. For example, this is a combined command. So why I'm telling combined is that, for example, here we are using a program. So we are using program here. So ls is a program, this is a program. Also the ls here is also program, but ls home is a simple command. So this is simple command, simple comment here. So also these two are the, what I said, the program. But here all of these are a combined command. Oops, actually let's delete that. Yeah, all of these are a combined command. So here it is the combined. This is all of this code here. The command here is a combined command. So in this course, I will use the word command in all these ways. So usually the surrounding context will make clear which one I mean, but if not, I will use one of the more specific terms in our next lectures here. So pipes are essential part of the. So here, let's dive into building your piping skills with a small set of Linux commands. So no matter which one you encounter later, you will ready to combine them. So we will learn here let's actually draw this. So I will draw this here. So you will learn about firstly the WC. You will learn heat. You will learn heat here. So you will also learn cut. You will learn about the grep. You will learn sort, and here sort 1 2 3 4 5, and unique. And also, yeah, it's 6 here. Yeah, also ls here. So let's get started. So these commands have numerous options and modes of operations that I largely skip for now, just now, to focus on pipes. So to learn more about any command, run the man command here. Oops, why it's like that? Yeah, run the man command. Oops, yeah, run the man command like this. And for example, if I wanted to get an information about the ls, then the man command will give me a detailed description, the name, synopsis, description, and all of the information that I need here. Actually, we did learn this in previous lectures, but I just wanted to mention it again. So here, let's get started with the WC command. It's actually, yeah, here, clear, WC command. So the WC commands prints the number of lines, words, and characters in a file. So let's actually use for now, let's use the user interface for creating files, but in next lectures you will also learn how to create, delete, and manipulate files from the command line. So here let's create right click on it, create document, empty file, and let's name this file here Oxaly create, and here delete this, don't save. Here let's increase the font size a little bit and write something here. So Oxaly Academy, Typhoon, online Linux course, YouTube, we are on YouTube here, Oxaly, and here this is our text for now, and we will use WC animals to print the number of lines, words, and characters in a file. So it's gonna be like Oxaly, and here, as you can see here, we have 5 lines here and 83 characters, and we also have 5 words in these file lines here. So let's open what we have as a word. As you can see here, these, all of them, it counts as a word here. So let's add something with a space here and run this command again. As you can see here, we got 96 characters, 6 lines, 6 words, and 5 lines here. So WC reports that our Oxaly has 5 lines, 96 words, 96 characters. So if you count the characters by I, including here spaces, types, and new lines, you will find 96 characters. So, but WC also includes the invisible new line character that ends each line. So the option here, WC here, for example, WC L, W, and C, instructs WC to print only the number of lines, words, and characters respectively. Here, if I wanted to, for example, L, WC L, auxiliary, and here, as you can see here, we have five here. So we printed the lines here. So if we write it like this, WC C as a parameter, W as a parameter, we will print the words here, and WC C as a parameter, we will print the characters as a C for characters, W for words, and L for lines. So continuing is such a useful general purpose task that the authors of WC designed the command to work with pipes. So it reads from the std in if you omit the file name, and it writes to the std out. So let's use the ls and list contents of the current directory and pipe them to WC to count lines. So the pipeline answers the question, how many lines are visible in my current directory here, and for example ls L here, or ls1, and as you can see we have these files and folders in our directory. So if you write like that here, so ls1 and ls1, and we are using pipeline wc1 or L here, we will get 10. So let's count here: 1 2 3 4 5 6 7 8 10 11. 1 2 3 4 5 6 7 10 11. Oops. 1 2 3 4 5 6 7 10 11 12. So we have 12 files here, 12 lines here, as you can see here. Let's delete all of them. So that's because we have the ls, we counted the L with ls1, we counted all of these folders here. It's clear here. So now let's actually write something. So let's WC is the first command you have seen in this lecture, so you're a bit limited in what you can do with pipes. So just for fun, pipe the output of WC itself, so demonstrating that the same command can appear more than once in a pipeline. So this combines command reports that the number of words in the output of WC is a 4. So let's make this like that here. So we're gonna use the WC or auxiliary here, auxiliary, and this, oops, why, yeah, why, no, there's no such, or yes, we go on here, ls here, ls, yeah, auxiliary here. So WC auxiliary, and here we have this here. So if we write it like that, WC and or auxiliary, and WC W again, and as you can see here, we got 4 here because we are printed here. So let's actually draw that. This is interesting here. So this was our output, right? So our output was 5. Oops, actually it's here. Yeah, our output was 5 6 96 and auxiliary. Yeah, auxiliary. Oops, yeah, auxiliary. So here, let's count it. So this is our first word, 2 3 and 4. So as you can see here, with this command we get the 4 words, and we gave this command to WCW here. That's so as you know, we are with WCW we are getting words here. So we got 4 and not 6 here. So that's an interesting type with the Linux commands here. And let's actually do one more example. Why stop here, right? So let's add a third VC command to the pipeline of the count lines, words, and characters in the output for. So in order to do that, we will here. Oops, why are you doing this? Yeah, clear. So our output was auxiliary here, WC, and as you can see, we got a 4 in previous code command. So WC auxiliary, and here WCW, and we are using again here, so we're gonna use the WC here. So here the output indicates one line containing the number 4, one word containing the number 4 itself, and 2 characters here, and as you can see here, 1 1 2. So here here 4 here, the 4 ends with an invisible new line character here. So 4 ends with an invisible new line character. That's why we got this output here. So that's enough with the silly pipelines with WCM. As you gain more commands, the pipelines will become more practical. So see you in next lecture. Hello, my name is Tayfun, and in this lecture of our auxiliary course, we will use more examples with ls commands. ls is aware of whether stdout is a screen or whether it's being redirected to a pipe or otherwise. So the reason is friendliness. So when stdout is a screen, ls arranged its output in multiple columns for convenient reading. For example, ls bin here. Oops, here, look, not like this. Yeah, ls bin here. So home and Kali and ls here. So here, and make it clear and ls bin. Yeah, that's enough files here like for us. So this ls bin, so when stdout is redirected, however, ls produce a single column. So I will demonstrate this by piping the output of the ls to a command that simply reproduces its input, so such as cat. So for example, bin and cat. And as you can see here, we are seeing this just a one line in each here. So oops, we opened so much files right now by just clicking and like this, so we are not using it again. Unfortunately, we did it here. Oops, yeah, whatever. So now the behavior can lead to a strangely looking results like this. So let's actually create ls here. Oops, ls. Oops, ls here. And here, let's make it ls wc l here. And as you can see here, we have 10 lines, but as you can see here in the output, we have just one line. So the first ls command prints all file names in one line. So, but the second command reports the ls produced 4 lines. So if you aren't aware of the, no, actually it's 10 lines. So if you aren't aware of the quirky behavior of ls, you might find this pretty confusing. So ls has options to override its default behavior. So force ls to print a single column with a here -1 option. So we are seeing this now. We can also use force to multiple columns with the C option, so lsc, and as you can see, we use the multiple commands. So if you write, as you can see with this, we've got the ls with wcl, we got 10 as a result because we have 10 lines. And if we do it like that, for example, let's actually write it like that, C and wcl. And as you can see here, we got only 2 lines here. So ls is actually pretty strange if you wanted to understand it deeply here. And in this lecture of our Oxali course, you will learn about the heat command in Linux. So let's get started. So the heat command prints the first lines of a file. So to print the first 4 lines of our Oxali with here Oxali text file with heat, we can use the option N. So heat N4 and Oxali here. And as you can see here, we printed first 4 lines of our Oxali text file. So if you request more lines than the file contains, the heat prints the full file like cat does. So if you here, let's actually open, and as you can see, we have 6 lines here. So if you write it like that in 11, then it will just print the 6 lines here. So it will print whole file. So he can also read from the std informal pipeline fun. So a command uses to reduce the output from another command when you don't care to see all of it. So like a long directory listing. For example, let's list the first 5 file names in the bin directory here, so ls, or let's actually 15 file names in the bin directory. So bin heat, and it's gonna be 15, and as you can see, we printed first 15 lines in the bin directory. We also have the cut command. So the cut command prints 1 or more columns for a file. For example, let's actually here, so let's print all titles from the Oxali file which appear in the here. For example, cut f2 and Oxali here, and as you can see here, we got this here. So cut provides 2 ways to define what column is. So the first is to cut by field f here. So this f, when the input consists of string fields, each separated by a single tab character. So conveniently, this is exactly the format of a file of Oxali here. So the preceding cut command prints the second field of each file. So if you write it like that, 1 here or f3, and as you can see here, so we can also do that like that here, and let's run it again, and as you can see here, we got a different output. So to shorten the output, we can also use the pipe it to heat the print only the first 3 lines, and so on. So now let's actually use the grep command in our Linux command training here. So grep is an extremely powerful command, but for now I will hide most of its capabilities and say it prints lines that match a given string, like it here, grep Oxali and Oxali here. So Oxali is a text file, so let's actually change it from the UI here, oxali.txt. For if some of you are Windows users, you will understand that this is a text file here, but for Linux it's actually text files is not stored with a txt file here, so they are just stored a plain file. So here oxali.txt, and as you can see here, we got all the grepped, all the Oxali here. So for example, the command displays lines from Oxali that contain the Oxali string here. So you can also print lines that don't match a given string. So with the V option here, so grep Oxali and oxali.txt, these lines here, as you can see here, we will exclude all of the Oxali commands here. So in general, grep is useful for finding text in a collection of files, and we can also use command prints the lines that contain the string Perl in with the names ending here txt. For example, grep Oxali auxiliary and txt in a bin here, so we are not in a bin. So in this case, grep here, let's actually go to bin here, cd bin. We can also write it like that to give grep python and txt. Since I don't think we're gonna have here, as you can see here, we don't have any python here. So in this case, if you have a python here, the grep will find matching lines like it did in the auxiliary here and print it on the screen. So we also have the sort command. So actually, let's clear this, clear, and the sort command reorders the lines of a file into ascending order by default. So you can also change the descending or other orders here. So for example, sort auxiliary.txt, and that's not sort here, sort. So you cannot read auxiliary such file or directory because we are on a bin directory. So we're gonna go to home here, home, Kali and ls, clear. So sort auxiliary.txt, and as you can see here, it will sort our file. So let's actually edit file, so make it a little more visible like this. For example, write it Apple, BMW, computer, Zebra, Windows, Linux, and here. So now we're gonna write it like that, and as you can see, Apple, BMW, computer, Linux, Windows, and lastly Zebra. So it will write it our lines with it with ascending order. So this is by default. So if you want to change it like this, for example, sort from the descending order, so you're gonna write it like that, R here. So as you can see here, first the Zebra, Windows, Linux, computer, BMW, and that's lastly A here, which is Apple here. So the sort here can order the lines alphabetically by default or numerically with the N option here. So for example, if we write it like that, so actually let's write it here, numbers and 25, but we actually read it quite opposite here. So we ended with 98, and as you can see here, we ended with top numbers, but first we write it with the ascending order here, and as you can see here. So we can also write it descending order by adding after n, we can also add r here, so it will write at descending order, and as you can see, first we've written the highest number, and then it got to from the highest windows here, and as you can see here, this is it. So if you write like that, sort and r here. So now let's demonstrate here, for example, cat auxiliary.txt, and as you can see, we got this here. So we will use the unique auxiliary.txt, and as you can see here, we are not showing the same outputs again and again like this here. So notice that the unique reduced the first three lines to here single in the Linux here, and as you can see here, we got just one Linux, but here we also had two Windows. We got one Windows, and after that we are just seeing one Windows per line, and after that we are seeing another here. So we can also use the, for example, print the gray our lines with cut auxiliary.txt here. So, and we will also that sort, and here we will use the sort and unique C here, sort and R, and after that heat here in 1, and as you can see, we just got 5 Linux here.